For question 1, this is the chromatogram for analytes A and B. They also give information about elution time and peak width at base for column 1 and column 2. And the question asks, recommend which column is more efficient for chromatographic separation of component B. Give your recommendation based on the number of theoretical plates. And the resolution of two peaks depends not only on how far apart their retention time, but also on the peak width. Calculate the peak resolution, how well resolved are the peaks, and has baseline resolution been achieved? First part, to determine which column is more efficient, we need to calculate the number of theoretical plates. This is the formula of number of theoretical plates. And from the information given in the box, just apply the value from column A and from column 1 and column 2 into the formula of n, which is for component B column 1, the value of number of theoretical plates is 1111.11. Meanwhile, for column 2, component B, the value of n calculate is 330.58. Which column is more efficient? So the explanation is, based on the number of theoretical plates, column 1 has greater n value than column 2. This is because column 1 produces peaks with narrower bases. Thus, column 1 has greater n value and will be more efficient for chromatographic separation of component B. Meanwhile, for column 2 has smaller value of number of theoretical plates than column 1. This is because column 2 produces wider peaks. Thus, column 2 has smaller value of n and will be less efficient for chromatographic separation of component B. So, for part 1, we can conclude that column 1 is more efficient than column 2 for separation of component B. 2, we need to calculate the peak resolution and determine which one is well resolved. And also, which column is determine is column 1 and column 2 achieve the baseline resolution. So the solution is, first step is we need to calculate the peak resolution. This is the formula of peak resolution, and apply the value in the box given into the formula of peak resolution. For column 1, the peak resolution calculated is 1.82, while column 2 is 0.89. On the peak resolution value, column 1 has greater peak resolution value than column 2. For column 1, which is 1.82, it is larger than 1.5. It represents baseline resolution or complete separation of two neighboring solutes. This indicates a good separation and baseline resolution has been achieved. Thus, column 1 peak is well resolved than column 2. Meanwhile, for column 2, it is 0.89, which is smaller than 1, indicates poor and incomplete separation. The peaks are significantly overlapping and their baseline resolution do not separate and not achieved. Thus, column 2 peak is not well resolved than column 1. So, the conclusion is column 1 is better resolved, resolved better than column 2.
Question 2. The C18MS column used in this experiment is a highly nonpolar stationary phase due to the presence of long-chain alkyl groups, known as octadecyl groups, bonded to the siloxane backbone material. In reverse phase HPLC, nonpolar compounds interact strongly with the nonpolar stationary phase, resulting in longer retention times, while polar compounds interact less and elute earlier. Based on the chromatogram and properties of the compound, compound 3, which is the nitrobenzene, is the most polar due to the electron withdrawing nitro group, making it interact minimally with the stationary phase and elute first. Compound 1, which is an anisole, is slightly polar because of the electron donating methoxy group, which gives it moderate interaction with the stationary phase, causing it to elute after nitrobenzene but before benzene. Compound 2, which is benzene, is completely non-polar as it is a simple hydrocarbon and strongly interacts with the stationary phase, leading to the longest retention time and eluting last. In conclusion, the elution order is compound 3, followed by compound 1, and lastly compound 2.
Identify functional groups in the following FTIR spectra for the given chemical structures. Give your interpretation in the box. So as for the first one, the FTIR spectrum provided shows to correspond to cis-2-octane. The key absorption peaks identified in the spectrum are the first one at 3023 cm. This peak indicates the presence of double bond CH stretching, and it shows the characteristic of alkanes. And the second one is at 1660 cm. This peak corresponds to C double bond C stretching, and also is typical for an alkane functional group. This kind of spectrum is consistent with the structure of cis-2-octane, which contain a C double bond with the described alkane related absorption bands.
I will answer for question 3 to identify functional groups in the following Fourier transform infrared FTIR spectra for the given chemical structure. Give your interpretation in the box. I will answer for this FTIR spectra. Based on FTIR spectrum given, we can identify the functional groups in the CH3, CH2, CH2, C double bond O, and H2 compound. The functional group present are alkyl group, primary amines, and carbonyl group. Firstly, these two peaks with absorption peak around 3,500 to 3,100 centimeter -1 correspond to stretching vibration of NH bond is primary amine and H2. The second peak observed at less than 3,000 centimeter -1 in FTIR spectrum correspond to aliphatic CH stretching vibration of alkyl group CH3, CH2, CH2. The aliphatic CH bond usually absorb below 3,000 centimeter -1. Lastly, this peak with absorption peak around 1,755 to 1,650 centimeter -1 correspond to carbonyl functional group C double bond O with C-O bond stretching vibration. So the functional group of compound able to identify by observing the absorption peaks and the type of vibrations shown at FTIR spectrum.